Okay, so the final thing that we'll be talking about in the translation section is something called a rigid motion. Now, we are going to be doing this as a class, so really you should only be watching this video if you miss class. Or I guess maybe if you're getting ahead, but we are going to go over this as a class and do the activity with the partners. So if you're ahead, you might as well just wait till we do it in class. But anyway, so in isometry, this is a transformation that does not change the size or shape of a figure, and this is also called a rigid motion. So when shapes move around and their size and shape remains the same, these types of transformations are special and are called a rigid motion or isometry. So in translations, if you think about when an object translates, okay, when it moves, which I can kind of remind you from this slide, when an object moves with the translation, it does not change shape or size. Like if you guys see the original figure, the pre-image, when it slides diagonally, it still is the same shape and size. Now, it is in a different location, but the size and shape have remained the same. So a translation is an isometry or a rigid motion. It's very rigid. It does not change. Okay, so that is what an isometry and rigid motion is. So some properties of a rigid motion. Okay, it will preserve distance. So what that means is that every single point will move the same exact distance. So if you have 3 points in a shape, like if you're translating a triangle, all 3 of the vertex points, or the pointy parts, when they move, they will all move the same distance. Another thing, it will preserve angle measures. So after the object moves, okay, if one of the angles in your triangle is like 30 degrees, after it moves, it will remain 30 degrees. Another thing, it will preserve betweenness. So what that means is that if there's like a point between 2 other points, like if point B is in between A and C, so you kind of just have to picture it. If a point is in between 2 points, after it moves, it will still be in between 2 points. And lastly, this kind of goes along with what I just said, but preserves collinearity. That's a fancy word, right? So collinearity, what that means are when points lie on the same line. If points lie on the same line, they're called collinear. So if there are points that lie on the same line, so if you have a shape that has points A, B, and C all on one side of that shape, after it moves, those 3 points will still be on the same side. So they're going to remain on that same line. So that is kind of more detailed of what a rigid motion. But pretty much if it doesn't change shape or size, sorry guys, it is a rigid motion or isometry. Okay, so you will be answering these on a piece of paper. What we're doing in class is we're going to be tracing the pre-image and then sliding that patty paper over the image, which I know this is the image because of the little primes on the A, B, and C. And after we slide them on top of each other, it'll be really easy to tell if it's rigid or not, because if you slide it on top of its image and it's the same shape or size, that means it is rigid. If it's not the same shape or size, then it's not rigid. So you have to be careful. Okay, so on this one, it says in example 5, the figures below show the pre-image triangle ABC and the image triangle A prime, B prime, C prime under a transformation, which this will be, it looks like a translation then rotation. Maybe it's reflecting over a line though. But yeah. Alright, but anyways, determine whether the transformation appears to be a rigid motion. So probably just looking at it, you can figure out if it's a rigid motion or not. So do you think when you went from triangle ABC to its image, did it change shape or size? It did not change shape or size. So when it does not change shape or size, then it is a rigid motion. So this one, yes, it is a rigid motion because the transformation does not change shape or size. So on your paper, you will write that like right beside that picture. All right, the next one, let's look here. When I go from the pre-image to the image, what do you guys think? Did the triangle remain the same shape and size? No, it didn't. It changed. Okay, so when the shape changes shape or size, that's not a rigid motion. So this one we know the transformation does not change, or it does change, sorry, no, the transformation does change shape or size. So if it does change shape or size, it's not a rigid motion. If it doesn't change shape or size, then it is a rigid motion. So it's a little confusing. All right, and the last one. So we're going from the pre-image to the image. So again, you can probably eyeball it and kind of see. You don't necessarily need patty paper. If you want to use patty paper, just let me know and I'll give it to you. But again, if we trace this and slide it on over its image, what do you think? Is it the same shape and size? No, it's not. Aw, shucks. I hate when it's not the same shape or size as that. So since it's not the same shape or size, then it's not rigid. So this one would be no, the transformation does change shape and size. So it is not a rigid motion. So there you go. So that's just kind of going over types of rigid motions. We're going to go over two more types of transformations that will in fact be a rigid motion. So get ready for that. That'll be exciting. Nice job, you guys.